We've learned how to put together numbers using three different strategies, okay, three different operations in fact. So basically we have add and subtract, which is one type. We have times and divide. Okay, so we can put things together in groups. And the last one is powers and roots. And this is what we're going to look at. So we're going to look at powers and roots. So we have powers and roots. Okay, and it's important to understand how these things are connected. Adding or repeated addition is same as multiplication, but we never say that multiplication is the same as addition. And powers are repeated multiplication, but we can't say that repeated multiplication is the same or powers is the same as multiplication. The math for all these are very different. And we can connect the math for addition with multiplication, division with distribution. So for example, if I have 3 times x plus 2, we can't add x plus 2, but we can still multiply by distributing, where we have the multiply combining with the add and subtract. We also have this property of multiplication and powers, since they're closely related. We can say that we can do operations with these together. So the math behind these are compatible. So if I have 3 times a to the power of 2, we can do, although we can't do the multiplication then the power first, we can apply the power with the multiplication. So we end up with 3 squared times a squared. Okay. What can't be done, and this is very important, okay, what cannot be done is between addition, subtraction, and powers, these are not compatible. Okay, so we have to be very, very careful. And I'll give you an example of that. If I have 9 plus 16, okay, 9 plus 16 is 25. Square root of 25 is 5. So this is correct. We know that this is right. But since there's a plus there, we cannot apply powers through the plus, because powers and plus are not compatible. So if we did this, square root 9 plus square root 16, we end up with 7. We know that this is not true. So this cannot work. Okay, so we cannot apply powers and roots when there's pluses and minuses. Okay, so that's very important. So let's take a look at powers and roots. So powers and roots are the most powerful way we can put together numbers, and we usually use a power to increase numbers and roots to undo that power. Okay, so we have powers. Everything has an opposite in math, so powers and roots undo each other. So when we look at power 2, we talk about square areas. Okay, we're talking about squaring something, and that's our model for power 2. We square things in the area. Basically, squaring something takes a side length and makes it an area. If we square root, we start with the area and we end up with side length. So these are how the functions work. Okay, and cube, we think of volume. Okay, cube and cube root undo each other, so our model for cubes, we think of volume. And it's the same idea. If you cube something, you're going from side length to volume. If you cube root something, you'd go from volume to side length. So if I have 27 cubes, if I cube root it, I have a cube with side length of 3.